I'm going to go over graphing logarithmic functions. I recognize that you'll have the ability to type into Desmos, and I'll be showing you how to use that to help you with these graphs. But in terms of our transformations of logarithmic functions and their graphs, it's going to be very similar with how we've treated translations, moving horizontally, moving vertically, and then obviously with stretching or compressing, and then finishing off with looking at reflections, okay? So this first graph is using this formula here for the amount that we have invested into our account here. We've invested $2,500 into an account that offers an annual interest rate of 5% compounded continuously. So that phrase there, compounded continuously, means that we're going to be using that formula from an earlier lesson. Is the amount equals the principal, right, times the base e raised to the rate times time t. All right, and we use that base e when we're compounding continuously. So you can see this graph here. Now you'll notice because we're talking about actual money, we're not going to be talking about this moving into the negatives, but you get to a place where if you're investing, you could lose money. So we could be talking about moving in terms of this curve could be eventually going down, right, if something were to happen. But for our purposes, we're just dealing with this graph or this curve moving to the right and up forever. So let's talk about the domain. All right, the domain of a logarithmic function, right, is not going to be all real numbers. So right here, this domain is going to be, if you're talking about your parent function, it's going to be 0 to infinity. But the key thing to notice is that that is a parentheses around that 0. So 0 is not included because we cannot take the log of 0. We can do the log of 0.1, 0.01, but we can't do the log of 0. So that's why it's not included. You'll notice that the range, right, the range is going to be all real numbers. We are going to be going down and up forever, so no issues with that. So let's talk about the domain of moving this. You'll notice this +3 inside the parentheses is going to be a horizontal shift. You want to think opposite when you do inside the parentheses. So when I think opposite of +3, that's 3 units left. Okay, so in this case, for my domain, instead of being 0 to infinity, it's going to be -3 to infinity. All right, let's talk about this next one. You'll notice we have a horizontal shift of 2 units to the right. And we also have a vertical shift that +1 is 1 unit up. Now, because we're talking about domain, all right, that vertical shift is not going to have any impact on my domain, right? Yes, it would make the graph look different, but in terms of what x values I can use, it won't have an issue. So 2 units to the right, instead of starting with 0, we'll start with 2, and it's 2 to infinity. The key thing, guys, is make sure that you're not including that first number. Okay, now let's kind of graph some of these. I'll go ahead and I'm going to graph these two. All right, they've given you the points, but you can also go and type these into Desmos. Now we've graphed that basic exponential function, f of x equals 2 to the power of x, right? 2 to the power of 0 is 1. 2 to the first power is 2. 2 cubed is 8, which is going to be off the grid. So this is that parent exponential function. So this is 2 to the power of x. Let me change colors. All right, so I'll use blue for log base 2 of the power of x, So if I think about my domain here, remember we can't use 0, so we're going to use 1. Log base 2 of 1 is 0. Anytime you have an argument of 1, it's always going to be equal to 0. Log base 2 of 2 is +1. And then log base 2 of 4, so 4 is going to be 2. So it's going to look like this. It's going to increase forever. All right, but here's the interesting part. Because we get closer and closer, but we can never actually use 0, this creates what we call an asymptote. All right, so we actually have a vertical asymptote at x equals 0 that applies to my logarithmic functions. This is log base 2 of x. Now, I want to show you, and I've been trying to mention this a couple of times now in our lessons, but if I were to graph the line y equals x, right, as I mentioned in the previous lesson, the exponential function and the logarithmic function, they are called inverses of each other. So this line, y equals x, if they are reflective about that line, which you can notice that they are being flipped across that line, that's how you can confirm that these functions are inverses. Shouldn't surprise you. We've been talking about how exponential functions and logarithmic functions are inverses of each other, but I just wanted to put that red dotted line on there to show you and confirm again that they are inverses of each other. Okay? All right, so let's look at doing some graphing. All right, you can see some parent function characteristics here. You can see some on the right-hand side graphing the log base 2 of x, which we did earlier. All right, this is the parent function log of x. It's very similar to the log base 2 of x, and here is that natural log function with a base of e. All very similar characteristics. Okay, so let's plot log base 5 of x, and then we'll talk about the domain, the range, and the asymptote. So again, when I do log base 5 of 1, that will be 0, okay? And then log base 5 of 5 is 1. The next one would be 25. Log base 5 of 25 is 2, but that's way over off the grid. So I'm going to start graphing this. And then again, as we saw earlier, we have an asymptote at x equals 0. All right, so when it says find an asymptote, that's going to be a vertical asymptote at x equals 0. The domain is going to be 0 to infinity, like we had previously. And then, as I said earlier, the range is going to be all real numbers, negative infinity to infinity. All right, because even though it looks like it's kind of leveling off here, it still will increase. All right, we can still move to the right and up forever. Okay, so that's just graphing that basic logarithmic function with a base of 5. Okay, let's talk about using that horizontal shifts. Remember, inside the parentheses, you're going to think opposite, and then vertical shifts is outside. We're just going to do whatever the sign says. So again, inside the parentheses, I see minus 2. So that's going to be 2 units to the right. All right, so again, if you want to type this in to Desmos, you can. But I know I'll plot, let me plot this one first. I'll plot log base 3 of x first. So that's going to be 1, 0. Log base 3 of 3, 1, 2, 3 is 1. Log base 3 of 9 is 2, and then 27 would be off the grid. So here is the parent function with a base of 3. Now let's shift everything 2 units to the right. So I'll use red. So this is red for 2 units to the right. So red. 2 units to the right, 2 units to the right, 2 units to the right. All right, now what this is going to do is it's actually going to change what values I can start with. So you'll notice my asymptote, my vertical asymptote is not going to be the y-axis anymore. So my vertical asymptote also has to move 2 units to the right to be x equals 2. Essentially, if I try to plug in 2, you'll get log base 3 of 0, which is going to be undefined. So we can't do that. So that's why we have vertical asymptote at x equals 2. In terms of the domain, we're going to move that 2 units to the right as well to have 2 to infinity. But the range is going to be unaffected and still be negative infinity to infinity. All right, so that's it on shifting horizontally. Let's go and do shift vertically. I know I'm going pretty fast. You guys have done these shifts on lots of different functions before, so I'm not that worried about it. So this function says log base 2 of x plus 2. So we're going to do 2 units up. Good. So 2 units up. All right, so I'm going to graph that parent function, log base 2 of x, which is log base 2 of 1 is 0, log base 2 of 2 is 1, log base 2 of 4 is 2, log base 2 of 8 is 3. Oh, I can do another one. Log base 2 of 16 is 4. Incredible. So we're going to have all of those points to help me sketch this one. Notice again, I've got my asymptote at the y-axis. Now we're going to move all these points. Let's use blue. I'm going to graph this one, which is 2 units up. So count all these points 2 units up. All right, now because that's changing, the y values, it's actually going to have no bearing on the x values in terms of the domain. So my vertical asymptote is the same, still x equals 0. My domain is the same, 0 to infinity, and even my range is the same, negative infinity to infinity. All right? Now, stretches and compressions. These are the numbers that go in front. Remember, if your number in front is greater than 1, that's going to stretch it, make it increase faster, so make it look a little narrower. And if your number in front is between 0 and 1, that's going to make it increase slower or at a slower rate. So that means it's going to make it wider or compress it. So in this case, this 3 is going to be that stretch by a factor of 3. So I'm going to write down that's a stretch by a factor of 3. So let's go ahead and graph just the log of x, right? And the log of x is that base 10. So the log of 1 is 0. Log of 10 is 1. Now the next one would be 100, which is going to be 2. That's way off the grid to the right. So I'm going to go ahead and make that parent function right now. Okay, so again, there's my asymptote. You can see it as the y-axis. Now let's go ahead and graph this one, which is being a couple of things are happening. Not only are you going to have that stretch by a factor of 3, but you're also moving it 2 units to the right and then 1 unit up. So we also have a horizontal and vertical shift. Okay, so in terms of plugging in a value, I can plug in 3. 3 minus 2 is 1. Log of 1 is 0. And 0 times 3 is 0. 0 plus 1 is 1. So it's going to be 3, comma 1. Then I can plug in 12, because 12 minus 2 is 10. The log of 10 is 1. 1 times 3 is 1, or 3. 3 plus 1 is 4. Right? And from there, though, we're off the grid. We're going to have to plug in a number over 100 to get another actual whole number. All right, so the key thing is notice your new asymptote, because we moved 2 units to the right. So my vertical asymptote is now x equals 2. And then my domain also has to be shifted 2 units to the right. So 2 to infinity. And my range is actually not change, negative infinity to infinity. Okay? If that's a little confusing, don't forget you can always just type this into Desmos and see how it's changing. I like to type in the parent function so I can see how it's being translated. Okay, let's talk about reflections. You know, when I've done reflections in the past, I've told you guys that if you think about the opposite letter or the other letter in terms of your axes, that can help you see how to reflect. So like, for example, if I were to just focus on this negative with the x, when you make the x the opposite, I'm thinking of reflecting over the other letter axis, so that's over the y-axis. If you think about this negative in front, that's the opposite of the entire function. So the opposite of f of x, which is y, the other axis is x, so that would be reflection over the x-axis. If that's confusing, don't worry, where you have graphing technology to help you. And I actually do want to show you what all this looks like, because I think it's can be interesting to see as you go, right? Because this has 2 reflections. Let's just do one at a time. So let's plot first the log of x. So just the log of x, all right? So here we go. There's the log of x. Now let's go ahead and do one of them at a time. So I have the opposite of x. You'll notice, as I mentioned, if you think this is saying the opposite of x, so it's a reflection over the other letter axis, so over the y-axis, okay? Now if I put that negative in front, you can notice that I said it's going to be a reflection over the x-axis. So the purple one, which is my original, has been reflected over the x-axis. And then now it wants me to put them all together. So we're reflecting over both axes. You can see that my answer that I'm going to graph is going to be this blue one. So you can either go purple to black to blue, or you can go purple to red to blue. The idea is it's your choice, but I wanted to show you all 4 in this idea, all right, of reflection. So if I were to use that blue one, as I said at the end, that's the one I'm graphing. So I have -1, 0, right? Because the log of the opposite of a -1 is 1. The log of 1 is 0. The opposite of 0 is 0. All right, but as you notice, we have that vertical asymptote is the y-axis, right? And we're actually going to be moving this way, all right? So that's going to have the same vertical asymptote that I've used in the past, but my domain is going to be a little bit different, a little trickier. Remember, read it from left to right. So it's actually going to be negative infinity. The reason we can plug in negative numbers is because we will be taking the opposite of them before we do the logarithm. And then we're going to get all the way to 0, but we can't use 0, all right, because we can't take the log of 0. For the range, I know it looks a little funky, but you're still going to have negative infinity to positive infinity. All right. So hopefully having Desmos at your fingertips will help you with that. Don't forget to try the links, and good luck.